So we've done factoring, of course. We did a lot of factoring that showed up on our last unit test, and we're really building off of that in order to be able to factor a problem that looks like this. But if we just used the techniques that we have from before, we could actually get ourselves into a little bit of trouble, or at least be mostly right without being all the way right. And that's what we have to work on. Because if I looked at this just with the knowledge we had from our last section, the first thing I'd do is I'd figure out what A times C equals, and then that would tell me that I want to add to 1,200 and multiply to 350,000. That could take a while, right? That looks like really big numbers, a real pain. That's not the route that we want to go down. And so, rather than doing that, there's another technique that we can employ first, using, again, knowledge that you already have, which is to start by looking at every single term and seeing what I can factor out of every single term. So, looking at each term individually, what can I divide them all by? Yeah, since they all end in double zeros, we want to divide them all by 100. So I'm going to start by factoring out 100 from this whole thing. So when I do that, 100x squared divided by 100 just gives me x squared, plus 1200 divided by 100 is 12, so that's going to be 12x, plus 3500 divided by 100 is 35. Now, for a lot of problems that we've done earlier this year, that was it. We could factor out the greatest common monomial like that, and we'd be done. But in this case, and this is the new riff that we're having to deal with on today's work, is that the result that's inside the parentheses there, our quadratic trinomial, is still factorable. And so I now need to take it one step further. The 100 is going to stay out front, but I'm going to be splitting that quadratic into two sets of parentheses. And all I have to do when doing this is only to look at the quadratic. The 100 is just hanging out front at this point. It doesn't change how we approach this factoring on the inside. So I need to factor x squared plus 12x plus 35. That's one of the easy ones, thank goodness, because it just starts with an x squared. All I have to do is figure out what two numbers add to 12 and multiply to 35. What are those two numbers? 7 and 5. And so then this would actually be our completely factored version. Now, we have to do it and get it down to this point. There are other ways that you might end up writing this if you didn't factor out the 100 first, and it's actually going to make it a lot harder to work with. Let me take a look at what those would be. If you did not factor out the 100 first, but instead added to 1200 and multiplied to 350,000, if you did all that work, there's one of three options you would have come up with. You might have come up with 10x plus 70 times 10x plus 50. So if you had done all that work, this is one thing that might have happened. Now notice that if I take a look at this version, I can divide that parenthesis by 10 and this parenthesis by 10, which means it's not totally factored. There's still something I could pull out of the parentheses, and hence this would be considered partially factored but not completely factored, and we need to always be completely factored. The other options you might have come up with would have been 100x plus 700 times x plus 5. You'll notice in this case I could divide that first parenthesis by 100. So therefore, only partially factored, not completely. Or you might have come up with x plus 7 times 100x plus 500. Again, notice in the last parenthesis, I can factor 100 out of both terms, therefore again, not completely factored. So while each of these would be considered partially factored, they would not be considered correct when we are asked to factor these, because factor means write it completely factored. Alright? So that's part of the key about starting by pulling out whatever the biggest common monomial is. Now, if you don't get it right away, yes, there are ways you could work from one of these forms and still get to the correct final answer. it just takes longer to get to those forms, and then it can be potentially a little wonky if we aren't really careful with it. So just watch out and ideally catch the biggest one you can pull out at the start. All right, next problem. Go ahead and write this one down and start working through that factoring process. See how far you can get through it. Right, so as you go to factor that quadratic on the inside, it is one of the trickier quadratics. So I got to multiply a times c, which gives me negative 252. So I'm trying to figure out then what two numbers multiply to negative 252, but add to 4. And then we're going to use that to break up the 4, so it's going to become 12x squared. Then we're going to break up the 4, and the minus 21 will be hanging on the end there. Should find plus 18x and minus 14x. And so then we can go ahead and factor from there, of course. We take a look at the first two terms, factor out the biggest thing we can there, which looks to be a 6x. That turns it into 2x plus 3. Then we look at the second two terms. Now remember, I want the x term to be positive, so I'm actually going to pull out a negative 7 there, which gives me 2x plus 3. Good, the parentheses are the same as we go. That's what we wanted. All right, so then I go ahead and factor from there, so I can pull that 2x plus 3 out of both terms, and that leaves me with a 6x minus 7. Now, if you wrote that as your final answer, though, it'd be incorrect. Do you see why? Yep, the 5. You notice while I was doing the work, I didn't write that 5 in. It does need to be in our answer. And in fact, technically speaking, I should really be writing the 5 in on each of these lines as well in order for it to technically be the same thing. But really, I just did that work there in blue just to kind of show my work. Because I found that if I write that 5 out front, it's just one more set of parentheses that gives people headaches and causes confusion and helps us lose our way in the problem. So technically, yes, the 5 is there at every step of the way, but if you leave it off just while you're doing the work to make it a little bit easier for you to read, I'd understand that, and I'd be okay with that as a compromise for being able to have clarity in your process. So the first thing we look at with this one is we look to see if there is something I can divide out of every single term. Now the 18 and the 30, we're pretty familiar with numbers that go into those. 57, we aren't quite as familiar. So I start testing with the 18 and the 30, and I notice that I can take a 6 out of both of those, but I know I can't take a 6 out of 57 because 6 is even, 57 is odd. 3, I can pull 3 out of those. Is 57 divisible by 3? Yeah. Do you remember how you can tell without your calculator as well? I showed you this little trick once before, but it bears repeating. It only works for 3s, but add 5 plus 7 are 2 digits. That's 12. Is 12 divisible by 3? Yes. Therefore, 57 is also divisible by 3. It's a cool trick that works with 3s. But in this case, I am not actually going to factor out a 3. Because if I just factor out a 3, I'm going to end up with a negative 6x squared. And all the factoring we've always done, we've always kept it a positive. In fact, I want it to stay a positive x squared. It makes a few things a bit easier along the way as well as the factoring. So I'm actually going to factor out a negative 3. So knowing that, you can factor out your negative 3, and then once you've done that, go ahead and finish solving it, or factoring it rather, from there. So you notice the first thing you have to do is figure out, okay, 6 times 10 is 60, so what two numbers add to the negative 19 but multiplied is 60? And you should find those two numbers are negative 4 and negative 15. Notice they both need to be negatives because we're adding to a negative but multiplying to a positive. Then go ahead and factor out of those first two terms. I can pull a 2x out of both of those. And then factor out of the second two terms. Again, I want that x term to be positive, so factor out a negative 5. Oops. There we go. And then we can go ahead and finish factoring it out from there. So we end up with 3x minus 2 times 2x minus 5. And again, make sure that you remember that we're not done here. I have to carry down that negative 3 from earlier, and it still needs to be hanging out front of the whole thing. If you find yourself having a tendency to forget it, well then put the parentheses around every step of the work you do here and write that negative 3 out front of it, just as part of your work.